Up to this point, we've just found a few derivatives. The derivative of negative 3/5 x plus 2 is negative 3/5, which makes sense because this is a line and this is the slope of that line. The derivative of 3x squared plus 4x minus 1 is 6x plus 4. The derivative of x cubed minus 27x is 3x squared minus 27. The derivative of square root of x is 1 over 2 square root of x. Now, this one is not as obvious, but it does follow the pattern, but the pattern isn't going to be very clear. So let's just look at those right there, and let's see if we can figure out a pattern. So it's kind of hard to do in a video because I want you to think, see what you can find, and we'll move on to the next one. So pause the video if you want to. See if you can notice a shortcut. And again, the shortcut applies here, but it's not as obvious. So here goes. I would like to think that that's obvious because that's the slope. Let's find the derivative of y, which will be y prime equals. Okay, if you know the shortcut now, pause it if you want to. Try to find the pattern, sniff out the pattern. If you don't know the pattern, I'm not going to tell you yet because I want you to kind of figure it out, but let me give you another example. Negative 8x plus 2. Okay, let's find the derivative of this one. The derivative of 10 is, excuse me, is 0. The derivative of 10 over x is not obvious. It's a lot like this one where it's kind of hard to find. So we're not going to play that game yet. Let's just pause and figure out what the rule is. And I hate to blurt it out, but here goes. Let's go with this one. Negative 4x squared, that term, the derivative of that specific term was negative 8x. Do you see where the negative 4 came from? I'm sorry, where the negative 8 came from? Yeah, I hope so. Negative 4 times 2, negative 8. Okay, well, it's just x now. It was x squared, but now it's x, and here's why. Whatever your exponent is, subtract 1. So this is 2 minus 1, so 1. So we'll do the same thing here. This is 2x to the first, so 2 times 1 is 2, and completely unnecessary, but I'm going to write it anyway. Subtract 1 from your exponent, so I'd have x to the 0, which is just 1, right? So it's like 2 times 1. This minus 5, well, this is minus 5x to the 0, so then I would do 5 times 0, and I would just get 0, so plus 0. There you go, and that's where that one goes. And that's why this one is just 0. And now let's do a rewrite on this one so we can find the derivative, because this one's not as obvious. This is the same thing as 10x to the negative 1. So now we're going to multiply 10 times negative 1. We'd get negative 10. This is not the derivative. This is a rewrite. And we will subtract 1 from our exponent, which gives us negative 2. And this is correct. Oops. Let me move that down a little bit. What we're going to do is rewrite this again. This is completely correct, but we're going to write it using positive exponents. There we go. Okay, same idea on this one, but let's do a rewrite first. So before we ever find the actual derivative, we need to do a rewrite of the cube root of x, and the cube root is the same thing as x to the 1/3. Okay. So let's do the same rule that we've been doing, which is 1 times 1/3. And then we will take the exponent and subtract 1. So 1/3 minus 1 is negative 2/3. Okay, let's stop right here. We're not done, but we're going to pause right here and make some sense of this crazy one up here. And this one was really x to the 1/2, right? Well, the derivative of x to the 1/2 would be 1/2 x to the negative 1/2, because we would subtract 1 from that 1/2. So when we do that, we're going to have 1/2 x to the negative 1/2. This negative 1/2 makes the x to the 1/2 go to the denominator. And then this x to the 1/2 is a square root, and that's why that turns into this. Okay? All right, let's finish these 4 problems down here that require just a little bit of effort. We'll be okay though. First of all, we can factor this one, and we would say that it's x plus 1, x plus 5 over x plus 5. There we go. And we can cancel those. And so that would be x plus 1, which is perfectly fine. However, I do want to throw a little bit extra out there. We can't just say that h is equal to this, because that's not true. Because if I said that h equaled this, then I would just keep on graphing. But actually, I can't graph at x equals negative 5. So I'm going to throw a little bit of extra in there and say that x does not equal negative 5, because that's the thing that canceled out. There's a hole in the graph there. So now we'll find the derivative, and I'm going to find the derivative of x plus 1. It's the slope of x plus 1. We can use our shortcut if we want to. We could say 1 times 1 gives me 1, right? And then x to the 0. And then the derivative of 1, the derivative of a constant, is going to give me 0, because this is like 1x to the 0. And that's fine, but I'm also going to say, you know what, this derivative does not exist at negative 5, because the function didn't exist at negative 5. I have to have continuity to have differentiability. Okay, let's move to the next problem, and we're going to do a little rewrite. It's going to take a couple steps. We'll do x squared over x, 6x over x, and 5 over x, and then we'll go one more step with this, and we're going to say, well, x squared over x is really just x. 6x over x is just 6. And 5 over x, and you can leave it as 5 over x, but for the sake of where this is going, I'm going to make it 5x to the negative 1, just to make it a little easier to look at as we take the derivative. Sometimes you do a massive rewrite before you actually take the derivative. So the derivative of x, the slope of x is 1. The derivative of 6 is 0. And the derivative of this would be 5 times negative 1, so negative 5. Subtract 1 from your exponent. And this is correct, but let's do a little rewrite. So 1 minus 5 over x squared. Okay, now we have some disgustingness. Let's do a rewrite on this one. We have a coefficient of 6, and x to the 5/4, and then plus x. And we'll do the derivative. Okay, coefficient times exponent, there's your shortcut, and then subtract 1 from the exponent. I haven't articulated it like that so far, but coefficient times exponent, subtract 1 from your exponent. So 6 times 5/4, that is 30 fourths. Yes, it reduces. We'll take care of that in a minute. Go ahead and do it now if you want to. It's 15 over 2. X to the, 5/4 minus 1 is going to give me 1/4. And then we'll take the derivative of this guy right here, and that would be plus 1. So this is correct. Let's do a little rewrite on it. First of all, that plus 1 is not too special. He just doesn't get much of a rewrite. This will reduce 15 halves. Could have done that earlier. And x to the 1/4 is the 4th root of x. It doesn't move numerator to denominator. It's positive. The exponent is positive, so it stays where it is. Okay, last one on the front. Let's do a little rewrite. There we go. And then f prime of x is going to be equal to, let's take the derivative, negative 32, x to the negative 3. Negative exponents will move, so x cubed and negative 32 up